Hi folks, and welcome to Maths and Physics for You. Today we're going to do the Ferris wheel as a cosine function. This is a common problem that comes up in assignments, in exams, in high school, in university, in engineering, design. So let's see how we can write or model the motion of a Ferris wheel. That is the height with respect to time. Let's have an example like this. The Ferris wheel, it has a radius of 25 meters. The radius is 25 meters, and the lowest point is 5 meters above the ground level. And the full circle is completed in 4 minutes. Okay, so we are required to write a cosine function that represents the height with time, with respect to time. All right? Yeah. Okay, then let's see what we're going to do. Okay, as we know, the basic cosine function has the following shape. See, let's say a cosine function. Y equals cosine x, or let's say 2 cosine x. Okay. Now, this should be 2, and this is minus 2. The amplitude is 2. The amplitude is 2. That is, the highest point is 2, and the minimum point is minus 2. Okay. Now, here we have the period is 2 pi. So that will be pi. This is half of it, pi over 2. And this is 3 pi over 2. Okay, simply, so we are doing this quickly just to compare with how we do that. So 1x is 0, the cosine 0 is 1, so y is 2. So this is 2, so we start at 2. So it goes like that. So this is the shape of the cosine function. Okay, this is the shape of the cosine function, like that. But what we got here is upside down. See, so it's the cosine function but flipped. This means instead of having 2, we could put minus 2 to reflect it. So if we put minus 2 here, then it will be reflected about the x-axis. So it will be the other way around. It will be like that. This one, the blue one. So this is comparable to this one. Alright, so as we can see here, this is the Ferris wheel, this is the height, this is the ground level. We put the x-axis for the height here, and this is the time. One full period is 4 minutes. Half of it is 2 minutes, 1, 3. Now, at time 0, the height is 5 meters. So if you're sitting here, right, yeah, so the time, at this time, your height is 5. After 1 minute, when it starts rotating, your height will be 5 plus 25. So you are adding 5 plus 25. So you are 30 meters above the ground level. So you will be, after 1 minute, you will be at this point, 30 meters. All right? Now it continues like that. So after 2 minutes, assuming uniform circular motion, as the speed is uniform, you will be at this point. The highest point will be 55 meters. That is 30 plus 25, or 50 plus 5. So here, after 2 minutes. It continues like that. So after 3 minutes, you are back. Your height is back to 30 meters. Again, after 4 minutes, you are back to the lowest point where you started. So this is full cycle. This is the period. This is full cycle. So the period here is t equals to 4 minutes. All right? But again, comparing now to this one, you can see that the center line is here, the x-axis. That is x equals 0, y equal to 0. but here it is not. The center line is this one. That is H here. This is the center line, as you can see, of the graph, of the cosine function, the cosine graph. This is the center line. So the distance from here to here is, what's the distance from here to the center line? This is the shift, upward shift. This is what they call the upward shift. This distance is 30, as you can see. At this point, at this height, h equals 30. So we have a shift of 30 meters, right? So it is. This is the cosine function. So that's how we relate it to cosine function and make it easy to find the cosine model. Okay, so we have a vertical shift equals 30, right? So the equation will be something like this. H equals, we know a number, A, cosine, you know, Bt, plus, call it C now. C is the vertical shift, so C is 30. C, this is equals C. This is C. All right, understood? Okay, so we replace C with 30. As simple as that. Now A, as we know, is the amplitude. What is A? A is the amplitude, right? The amplitude is halfway between the maximum and the minimum. The amplitude is halfway between the maximum and minimum. So this distance, as we see, from 55 to 5 is 50, and half of it is 25. So, right? So we can say this is 25 and this is 25. So here, this means A is not just 25, it's minus 25, because as we saw, that it is a reflected cosine function, so it's a negative. See, the amplitude is 25, but the number A here, A is not always the amplitude, if it is a positive. All right, so this number A, now we can replace it with minus. Okay, minus 25. All right, so we have, that's amplitude equals 25. But A is minus 25 because it's reflected. Now what we have to do is to find B. As we know that the period, we know B is related to the period as 2 pi over t. This is the relation. This constant here is the frequency, actually. What is B? Is the frequency of rotation. How many rotation, for example, per minute, or based on what units you use. Okay, so this means we have, but t here is 4 minutes. Okay, so that's, we say 2 pi over 4. Okay, so as simple as that. So we replace B with 2 pi over 4. Easy? Yeah, so that's basically that's it. So this becomes over 4, and that's what, of course, the variable is t. Of course, we can simplify. We make divide by 2, so it becomes pi over 2. But it's alright, even we can leave it like that. Even if you want to simplify, that's fine. So this becomes pi over 2. Divide each side by 2. Okay, so that becomes pi over 2. Alright, yeah. Okay, let's make them the same color. Okay then. Yeah, so this is the equation, what the one we want, the one we are after. So this is the equation that represents this motion. But to be satisfied, we have to check and test it. Okay, simple. Let's see. Let's look at this now. All right, we write it here. This one, d equals 2 pi over t. All right. Yeah. Okay. Let's see. 1 times 0, h0. Check. So this is h0. Okay, what is we substitute here, this becomes cosine 0, so minus 25 plus 0 plus 30. Okay, cos 0 is 1, so minus 25 plus 30, minus 25 plus 30 gives you 5 meters. Yes, that's the one. So because at times 0, it's at 5 meters. Okay, same thing, let's say 1t is 1. Okay, h1 minus 25 goes pi over 2 plus 30, because you're multiplying by 1. You multiply by 1. What is cosine pi over 2? Cosine pi over 2, as you know, cosine 90 is 0. Cosine 90 is 0. So we are left with 30. So that becomes 30. So we look here, yes, after 1 minute, h is 30. So that's all good, right? And now h, let's say, after 2 minutes. So that will give you minus 25 goes pi over 2 times 2 plus 30. 2 and 2 cross out. So cosine pi is minus 1. Cosine pi is minus 1. So we have here minus 25 times minus 1 plus 30. Now minus 25 times minus 1 is plus 25. So plus 30, that will give you 55. And that's what we are after. As you can see, this is 55. And finally, h equals 4. After 4 minutes, completing the cycle, as you know, we expect that it comes back to the same point, that is, h should be 5, so that will be minus 25 cosine pi over 2 times 4 plus 30. Again, divide by 2, 1, divide by 2, so that's 2, 2 pi. Cosine 2 pi is 0. Cosine 2 pi is 1. Cosine 2 pi is 1 because it's back to the x-axis. So this you got minus 25 plus 30. And the answer is 5. So this means that this is verified. We verified the equation. It's correct representation. So this becomes the model for this Ferris wheel. As simple as that. I hope you enjoyed it and benefited from it and liked it, and please subscribe and see you in the next video. Thank you.